Good morning, class. Here's exam 3 review covering from 3.5 to 4.2, 3.5, implicit differentiation and related rates, all the way to how derivatives affect the shape of a graph. First, I want to remind you of this pledge. Before starting the exam, please read the following. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam. Unauthorized action include but are not limited to the use of notes, text, graphing calculators, etc. The point being, you're taking the exam as though you're on campus. You're taking it on your own. I can't emphasize this enough. That is my assumption. We start with differentiation formulas, reminding everybody of the definition f prime of x, the limit of f of x plus h minus f of x over h as h approaches 0. E in two different formats is defined. Basic differentiation formula, such as the derivative of a constant is 0, the power rule, the derivative of x to the power of n is n x to the power of n minus 1, and these are trigonometric functions. Product rule, quotient rule, composite function, giving rise to the chain rule, the derivative of f of g because f becomes f prime of g of x or g prime of x, or dy dx is dy du dx. And the power rule becomes the extended power rule, the derivative of g of x to the power of n is n, g of x to the power of n minus 1, g prime of x. The derivative of any exponential, it starts with itself. So e to the power of x is itself, e to the power of kx itself times k by the chain rule, e to the power of g of x times g prime by the chain rule, b to the power of x itself times ln b by the logarithmic properties, b to the power of f of x itself times ln b times f prime of x. Logs, if you want to take the derivative of logs, you just write it's the reciprocal of its argument. So if it's g of x, 1 over g of x times g prime of x when you have natural log. As we look at the graph of y equals f of x and point P and Q are connected, if we look at the concept of the run and rise, run as we go from P to Q is delta x or dx or this distance BP. Rise, it depends whether you're looking at the curve, becomes delta y, which is f of x plus delta x minus f of x, which is this distance BQ. But if you're looking at the rise along the tangent line, is this distance AB, which is f prime of x dx, and that can approximate delta y. Linearization simply means find the equation of a tangent line, and you can go with the point slope, eventually becomes this, but if you go that route and using that formula, make sure you simplify it and put it in slope-intercept format. Logarithmic properties, if b is larger than 0 and b is not equal to 1, then log x base b equals y with the arrow is equivalent to b to the power of y equals x. This is easy to follow with this arrow, and therefore it gives rise to a lot of logarithmic properties that you should be comfortable. If the base is 10, we call it common log, and we don't write 10, we just write log. And these are the properties. If the base is e, we write lnx. These are the properties coming from the general form. The two functions, logarithmic functions, exponential functions, are inverse functions. Therefore, they are symmetric with respect to the line y equals x. This is the change of base formula. Log x with any base could be log x over the same base with any other base. For example, log x over log b, ln x over ln b, log x over log b uses base 10, the common log, and this one is using a natural log. Y equals ln x has the x-intercept 1, 0. If x is between 0 and 1 here, it's negative, it's below the x-axis. If x is larger than 1 here, it's above the x-axis. And as it was mentioned, the derivative of ln x, just write the reciprocal of the argument. If it's g of x, 1 over g of x times g prime. And of course, if the base is not e, and you're looking at the derivative of log of f of x sum base b, 1 over f of x, f prime of x by the chain rule, 1 over ln b by the logarithmic properties, or more specifically, change of base form. All right, let's start with implicit differentiation. We want to find dy dx, where 2x plus y to the power of 4 is x minus 2y. So reminding you that the extended, and we're going to look at the very first piece. The derivative of g of x to the power of n is n g of x to the power of n minus 1 g prime of x, the extended power rule. So the derivative of this piece is 4 times the same thing to the power of 3. And then the derivative of the inside is 2 plus y prime, or dy dx. Then on the right side, x is 1 minus 2y prime. And we're done with calculus. So let me put an asterisk again. This is the only calculus step. Now we are going to distribute the 2. 2 times 4 becomes 8. And this one, we just write it as a y prime. So one more time. 2 times 4 is 8 times 2x plus y cubed. And then you write this piece intact times y prime. You are distributing. Because we want to solve for y prime, anything involving y prime should come to the same side. That means you're going to move this to the left and make it positive 2y prime. Move this to the right and make it minus 8 times 2x plus y quantity cubed. On the left side, although I can take the common factor of 2 times y prime out, I'm going to just take the y prime out. When I take the y prime out, I get this piece, 4 times 2x plus y quantity cubed, plus this piece 2. The right side is intact. Just divide by the brackets. dy dx, or y prime, is the right side, 1 minus 8 times 2x plus y quantity cubed, divided by the brackets, 4 times 2x plus y quantity cubed, plus 2. Now, the denominator has a common factor of 2. If the numerator happen to have the same thing, you have to simplify the fraction and put it in its lowest term. If it doesn't have it, so be it. We're going to differentiate sine y plus 2x cubed y squared equals 6. Even if they don't mention implicit differentiation, that's what we have to do. And so to do so, we start with sine. And as you know, the derivative of sine is cosine. So the derivative of sine x is cosine x. But the derivative of sine y is a function of x, like sine of g of x is cosine of g of x to cosine of y, times the derivative of g of x, which is dg prime, in this case is y prime, or dy dx. So that's the first piece. The second piece is the product of 2x cubed and y squared. We put a raised dot in between. We write it as f times g. And we use the product rule, f prime g plus g prime f. Which means the derivative of 2x cubed is 6x squared times g y squared plus g prime f. Y squared is 2y dy dx. You can look at the extended power rule or understand y means in essence g of x. So the derivative of y to the power of n is n, y to the power of n minus 1 y prime, or dy dx. So for y squared, since we use dy dx here, we're going to write 2 dy dx, and then times f 2x cubed. The right side is a number 6 or any other number, makes no difference. The derivative is 0. Again, this is the only calculus step. You're done with calculus. You are going to simplify and solve for dy dx, which means first we're going to rewrite this. We're going to rewrite this as 6x squared y squared, and then we're going to rewrite this as 4x cubed y dy dx. So since this has dy dx, this has dy dx, we're going to keep it, and this one moves to the right, becomes negative. Now, on the left side, we have only these two pieces, and we're going to factor out the dy dx, resulting in cosine y plus 4x cubed y. So again, these two, we factor out the dy dx, and this guy moves, becomes minus 6x squared y squared. So all we have to do, divide both sides by the parentheses, that's dy dx, and we are done. Dy dx is the right side, negative 6x squared y squared over the parentheses cosine y plus 4x cubed y. Find an equation of a tangent line to x squared plus 2xy minus y squared plus x equals 2 at the point 1, 2. Remember, to find an equation of a tangent line, we need two things. We need one pair, x comma y, it's given. We need the slope. That means we differentiate. And we plug in. When we differentiate, it's important to understand that's not the slope. Becomes the slope when we evaluate it at the given pair. So x squared gives you 2x. 2xy, we're going to put a raised dot in between. And we use the product rule. Two x, the derivative is 2 times g, which is y, and the derivative of y is y prime or dy dx times 2x. So this fg 2xy results in f prime g plus g prime f. Minus y squared minus 2y prime plus x plus 1. The derivative of 2, any number, is 0. And again, this is the extent of the calculus, believe it or not, and the rest is not. So let's simplify. Let's solve for y prime. So to do so, we are going to keep anything involving y prime here. So we're going to keep this as 2xy prime. We're going to keep this as 2y prime, and this moves becomes negative, this moves becomes negative, this moves becomes negative. Everything changes sign as we move it to the other side. On the left side, I can take the 2y prime out, but I'm interested in y prime only. So we're going to take the y prime, and we get 2x minus 2y. And all you have to do, divide the right side by the parentheses. Now, it's important to know, if the numerator has a factor of 2, since the denominator does, you must simplify. It doesn't have it. So if we plug in, we get 7/2. How do we get that? Let me show you. We plug in 1 and 2. Negative 2 times 1, negative 2 times 2, minus 1, 2 times 1, minus 2 times 2, and we get negative 7 over negative 2, which is positive 7/2. Y minus y1 is m times x minus x of 1.